Here's example 3 with using sum and difference formulas to evaluate trig expression. So examples 1 and 2 were in terms of degrees, now we're getting into radians here, so that's good. Okay, so evaluate the cosine of 11 pi over 12, so that's what we want to do here. So 11 pi over 12 is not a special angle on the unit circle, and we're talking about sum and difference formulas, so the idea then is to express 11 pi over 12 as a sum or a difference of two special angles on the unit circle. Okay, so I mean, that's usually kind of the hardest part, because once you figure that out, it's really just a matter of plugging numbers into a formula, and that's not too bad. So anyway, 11 pi over 12. So you can really just kind of do trial and error. So you can think, okay, well, something pi over 12, angles over 12 are not really special on the unit circle. So I'm going to probably want to break this up into a sum of two things, or a difference, but a sum will be easier, because 11 pi over 12 is large enough so that we can try sums. Now, if it were just pi over 12, that'd be different. But anyway, 11 pi over 12, it's large enough so that we can try sums of two positive things. So what we want to do is maybe have something that will reduce with 12 in the top. So something in the numerator that reduces with 12 so that we actually get like a 6 or a 4 or a 3 maybe. Something that will be a special angle. So one thing we could do is try, so 11 we know is 8 plus 3. So one way of splitting this up would be 11 pi over 12 equals 8 pi over 12 plus 3 pi over 12. Okay? And that's actually going to be a good way to go, because this reduces pretty nicely. So 8 and 12 cancel, and then this, so there's a common factor of 4 we can pull out, so that becomes 2, this becomes 3, and then over here 3 goes into 12 4 times. So 11 pi over 12 actually equals 2 pi over 3 plus pi over 4. Okay, so that's actually pretty nice. Now, it might not jump out at you right away to know to do, okay, 8 pi over 12 and 3 pi over 12. You know, you can try something else. You can try 9 pi over 12, which reduces nicely, and then 2 pi over 12, which actually also reduces pretty nicely. So that's actually another way we can go, is 9 and 2. You might try 10 and 1, but neither of those reduce. So, well, 10 pi over 12, that does reduce, but 1 pi over 12 does not. That's just kind of stuck as pi over 12, but that's not really helpful. Okay. So the point is, you know, just trial and error. You can try a couple things. There might be more than one way to do it. And here what we just found out was that 2 pi over 3 and pi over 4, if we add those together, we get 11 pi over 12, so that's good. So then cosine of 11 pi over 12 equals cosine of what we just found out is that's 2 pi over 3 plus pi over 4. Okay, so what we're going to do is use our formula sheet here. Okay, so we have cosine of one angle plus another angle, so we're going to use this formula here. Cosine of alpha plus beta equals this mess over here. Okay, so if you want a copy of this formula sheet we've been using in the last few videos, check the video description. There's a link there. You can click that link and get this formula sheet there. Not really a worksheet, I guess. Okay, so anyway, this here is our alpha, and this here is our beta. Okay, so alpha is 2 pi over 3, beta is pi over 4, and we have alpha plus beta. Okay, so cosine of alpha plus beta equals cosine of alpha, which is cosine of 2 pi over 3, times the cosine of beta, which is cosine of pi over 4, and then minus sine of alpha, which is sine of 2 pi over 3, times the sine of beta, and beta is pi over 4, so this is sine of pi over 4. Okay, and then from here, so these are all special angles, 2 pi over 3 and pi over 4, those are both special angles on the unit circle. Okay, that was the whole point of doing this, is to split this up as the sum of two special angles. So now it's just a matter of knowing the unit circle. So 2 pi over 3, pi over 4, we have to know the cosine and the sine of both of those. So let's come up here. Okay, and then that equals, so the cosine of 2 pi over 3, that's going to be negative 1/2, and then we're multiplying that by the cosine of pi over 4, which is positive root 2 over 2. And then we have a minus sine of 2 pi over 3. So minus sine of 2 pi over 3, that's a minus, and then the sine of 2 pi over 3 is root 3 over 2. And then we're multiplying by the sine of pi over 4, which is root 2 over 2. Okay. Okay, so then this is going to be negative root 2 over 4, like so. and then minus root 6 over 4. Okay, so we mentioned it when we did examples 1 and 2, but root 3 times root 2, if you multiplied square roots together, you can squish them under one square root, but that's not true for addition and subtraction, only multiplication and division. Okay? So now negative root 2 over 4 minus root 6 over 4, so this is negative root 2 minus root 6 all over 4. Or we can simplify and pull the negative out of everything in the top, okay, and then just pull the minus sign off, so that's actually going to be negative root 2 plus root 6 all over 4. A little more simplified there. Okay, so that's our answer there. Notice this is actually negative the answer we got for examples 1 and 2. So a lot of these sum and difference formulas involve answers that kind of look like this. So kind of interesting, kind of sort of. So anyway, that's example 3 with evaluating a trig expression using sum and difference formulas. And again, in the beginning, you know, if you're not really sure, if it doesn't jump out at you how to split it up as a sum or difference of two special angles, just try a few things. Okay, and if you see something over 12, you can think, okay, 12 is not the denominator in any special angle. But maybe if I can reduce that somehow to 6 or 4 or 3 or maybe even 2 somehow, usually 6 or 4 or 3, then we're in business and we can move forward. Okay, so that's why we did 8 pi over 12 and then 3 pi over 12. Okay, but again, you could also do 9 pi over 12 and 2 pi over 12. That was one other possibility. Okay, so and if you try that, you'll get to the same answer. It might look different, but it will be the same value. But anyway, that's example 3. Of sum and difference formulas for evaluating a trig expression, and here's the answer again.